Welcome to your own channel of Right Funda.
Here is a very interesting question from projectile motion kinematics. Let's read the question. Find the maximum angle at which a projectile can be fired such that its distance from the point of projection always keeps on increasing. Always keeps on increasing. So you read the questions. All of you try solving this problem. You can pause the video also. Okay. Hope you have tried the problem. Let's discuss its solutions. Reading this question, many times students get confused. That they think that this is the asking about the maximum range and they say the angle is equal to 45 degree. Whenever in the class I ask this question, people say that 45 degree. Because they have heard that maximum range is obtained, horizontal range, when the angle of projection is 45 degree. But the question is not asking that. Question is saying that what is the maximum angle at which a projectile can be fired such that its distance from the point of projection always keeps on increasing. So what does it mean? Let's see. Suppose a particle is projected with a speed v0. Okay, so it goes like this in a parabolic path. All of us know it goes in a parabolic path. So, and its position vector, if you keep see the position vector of the particles. So the position of the particle is like this at any point of time. So what is happening? The position vector will keep on increasing. If you see in this problem, this particular problem, will see what happened to the position vector. First position vector like this, then become like this, then become like this, then become like this, then become like this. So what happened? The magnitude of position vector, what happened? This become maximum or this become maximum, after that decreases. But question is saying that how it should be throwing, at what angle it should throw, so that it will keep on increasing. Suppose I say throw like this, then it will keep on increasing. Always next position vector length is more than the initial position vector, previous position vector. But if you keep on going like this, at a particular angle you start, this type of thing will start happening. First it increases up to this, suppose it increases. After that, sometimes this length is less than this. This length may be less than this. So question is asking the maximum angle at what you can throw so that the position vector of the distance of the particle from the point of projection keeps on increasing. Okay. So to solve this problem, first what you will see that what is given is v0 is given to us. So from this v0, we can write the first this velocity vector as a function of time, and we write the position vector, right? So what is the velocity vector as a function of time? Suppose the angle of projection in which the particle is projected is angle theta. Suppose some angle theta with a speed v0, it is projected. So we can write the initial velocity vector as v0 vector is equal to v0 cos theta I cap plus v0 sine theta j cap. Right, like this. So, and what is happening? The acceleration due to gravity is acting on this, and that will provide an acceleration of g is equal to minus j cap downward direction. So from this, we can write the position vector at any point of time is equal to r is equal to v0 cos theta t I cap plus v0 sine theta t minus half gt square j cap is the position vector at any point of time. At any point of time, position vector, we wrote this one. Okay. So these are two equations we got. One is the velocities, and for another we got for the position vector of the particle at any point of time in this case. So what will happen? The question is saying that distance from the point of projection will keep on increasing. And what is the distance from the point of projection? This position vector. From here to here, the position vector. So the magnitude of this should keep on increasing. So if I want to write the magnitude of this quantity's magnitude I want to write, then mod of this, I can write this the first x component square plus y component plus square. I wrote like this. And this should keep on increasing. So how to check this will keep on increasing? That let's differentiate and see the slope. The d by dt with the time increases if the rate of change is positive in there. If the dr by mod square by dt distance square ka differentiation is positive, means it will keep on increasing. If the negative, it will keep on decreasing. So first differentiate this with respect to time. So we can write this, we simplify first we'll simplify this one. So this a plus minus b ka whole square we wrote, and first simplify this one, arrange the term, that is equal to v0 square cos square theta, v0 square sin square theta, that will equal to v0 square. If I arrange this term, then I got this position vector in this format. Once I got this format, something into t square plus something into t to the 4 minus something into t to the cube, t cube. So I need to differentiate this with respect to time. So d r mod square, because then your distance will be keep on increasing, and distance square also keep on increasing. So I differentiate this one. So I differentiate this one. T square का difference 2t, 4 t to the 4 का 4t cube, and t cube का difference is equal to 3t square. We wrote this equation, and this quantity need to be positive. So if I take the t common out of this, t common out of this, two quantities I got. So second quantity I observed is a quadratic equation. See, this quantity is a quadratic equation, second term. So t will keep on increasing always, but this quantity should keep on increasing. So this I can compare with my a t square, ax square plus bx minus c, a t square minus bt plus c. This is a quadratic equation form is there. So this is my a, this is my b, and this is my c. And we know our method from quadratic equations, then if this type of equation remain positive only if this b square is less than 4ac. If this condition is satisfied, b square is less than 4ac, this condition is satisfied, then only this remain positive always. Okay, so this is a purely mathematical method we are doing, calculus methods we are solving this problem. So this, if I take in place of b, I'll write this one, a and c, I'll put this value, and I got this equation I can write as, in place I write the 3v naught g sine theta ka whole square. This will be less than equal to 4g square by 2v naught square. So this simplify this one, then I got the 9v naught square g square sine square theta should be less than 8v naught square g square. And if I take sine square theta, I can find out sine square theta is less than equal to 8 by 9, and I take the square root of this, then sine theta should be less than equal to under root of 8 by 9, or 2 root 2 by 3, 2 root 2 by 3, and theta should be less than equal to sine inverse of 8 by 9, and the 8 by 9 is just nearly equal to one quantity, and you will find out this one near this quantity sine inverse is equal to 70.5 degree. So if you throw the particle, so what we obtain from this equations, what you obtain, the two conditions you obtain, we will write down this two results what we obtain is equal to sine inverse of this angle of projection is less than this, then only the position vector will keep on increasing. Position vector will keep on increasing only if we throw the particle for a point of projection like this. This one method that we discuss is the purely calculus method. Let's solve this by another method. We'll be solving this by two methods we'll be solving. So we got this one. So let's see, go to the diagram and let's see what is happening. And here one quadratic, that equations we obtain is this equations. These are the equations what we obtain is after taking t common. I can write this and denote this also. So I got this equation in between where I check the I applied my knowledge of algebra, and to that this quadratic form, equation of quadratic form is there, and b square is less than 4ac or less than equal to 4ac, then only this remain positive quantity. Okay. If you see that, then let's solve by another vector method. See, so what is happening, you see that there is a position vector at any point of time, there is a position vector, or this is my position vector and this is my velocity vector. Okay, this velocity vector and position vector, if the velocity vector I resolve into two components along this and perpendicular to this. So if this is like this, if the velocity component is like this, then what will happen? It will be decreasing the position vector. But if I take a situation like this, suppose I draw another diagram, I'll draw, and suppose I draw a diagram, suppose take this one, is a projectile motion. So in which case there will be positive will be there. Suppose this is our position vector there at any point, and my velocity like this. So velocity of two component, one component like this, another component. This will be changing the direction. This will be increasing the distance. This distance part, d mod r will be increased by this component. So always there must be a component in the direction of r, then that will keep on increasing this one. In the previous problem, what happened, in some point of time, you see this, suppose I write this the position vector there and the velocity vector there. The velocity vector, when I resolve one component like this, another component like this. So this r is like this and the velocity like this. So this velocity is decreasing the distance. So always there must be an acute angle. There must be acute angle between the position vector and the velocity vector, so that velocity will have some component in the direction of r. So in my case, what should happen? This velocity like this, v is the velocity and r is the position vector. There should be a component of this. Between this angle should be equal to acute angle. This angle should be equal to acute angle. So beta is the angle is the acute angle. V and r should be angles. So to check the acute angle, we can take the help of the dot product. So first write the velocity at any point of time. if I write the velocity, that dot product b dot r should be greater than 0. If it is obtuse angle, then the negative quantity will be there. B dot r, dot product of b and r is a negative quantity, and b dot r is a greater than positive quantity, means angle is a acute angle. So v and r, right? V as a function of time dynamics, v naught cos theta minus I cap plus v naught sin theta minus gt j cap. So if I write this thing as the velocity as a function of time error and position vector as a function of time error, what I calculated earlier. So this dot product will do, then I cap will be multiplied, j cap will be multiplied, and I can write this equation like this, t times of this. So we got another conditions. So this quantity should be greater than 0. So what I got is that the quantity, what is the square bracket? You will see the quantity in the square bracket. So this you see, and if you compare this one, I put in a bracket, and if you see this one, this is the same quantity as we obtained earlier by all this calculus method and quantity, g square into t square minus another 3 b naught g sin theta t plus 2 b naught square. Same quantity we obtained by dot product of this. So now again we can say that this should be, what happened, should be positive. This quantity should be positive, and this is positive only if that again since the b square should be less than 4ac, that quantity will be calculating, and we obtain the same methods we will be doing. But here there we differentiated this one, but here we did the dot product, and we say that dot product should be greater than 0, that is a positive quantity, that be acute angle, so that velocity component should be in the direction of position vector. And again we'll be getting the same equation. Once you obtain same equation, after that process will be same, and we'll be obtaining the condition that theta should be less than equal to sine inverse of under root of 8 by 9, or that equal to 70.5 degree around there. So we solve the question. If the point angle of projection is less than this, then it will be going something like this, and position vector will keep on increasing. It might go like this also, keep on increasing forever. But if the angle is more than 70 degree, then will happen, the first time sometime it will increase, again it will be decreasing also, sometime it will be decreasing also. So we got the conditions like this, and we solve the problem.